All right, so today we are going to be learning about the states of matter. Have you heard states of matter before?
I think so. Like the United States?
No, these ones are the state that molecules are in. Do you know what molecules are?
No, I don't think so.
So I want you to think about Lego.
Okay.
Molecules are the little pieces that make up everything in the universe. So just like Lego, there's only so many types of Lego that there are, but if you put them together in different ways, you can have different things.
Oh, yes. Like when you use the small one and the medium-sized one, and then you can make a building?
Right.
Okay.
So molecules are the things, the little tiny pieces that make up everything in the universe.
Wow.
Okay. So we are going to look at 3 of the ways that those molecules are put together. Okay?
Okay.
So I want you to write down these words for me. These are going to be our keywords for today.
On this one?
On that one right there with your pencil. I want you to write solid.
I'm going to write cursive, Miss Khan.
You can write in cursive. Liquid and gas.
Wow.
Excellent. So by the end of this, you'll be able to tell me the definitions for solid, liquid, and gas.
Okay.
Okay. So I have some items here, and we are going to explore these items and see what you notice. So what do you have there?
A rock?
A rock. Yeah. Can you break it?
Nope. It's hard.
It is hard. Can you put your finger in it?
Nope.
No.
It's too hard.
It's too hard. So remember I said everything is made up of molecules. How do you think the molecules are put together in that rock? If you think about your Lego pieces.
Close, tight?
They are. They're very tight.
Close together because I can't break it apart.
Good. What's that?
This is a crayon.
It's a crayon.
I know this one.
What does that feel like?
This is hard too. I mean, I could break it if I put it hard, but...
Well, let's see. Go ahead, share. So even the piece that you broke off, see if you can have a look at the piece. How does that feel?
This is hard too.
It's hard too. And how do you think those molecules are together in that, if you were comparing them to Lego pieces?
They snap tight.
Snap tight? Similar to this one?
Yes, I can't get my finger in this one either.
Okay, so let's put these two together. Crayon and your rock. Alright, and I have something in this cup.
Ooh, that was nice and cold.
Nice and cold. So what do you have there?
Ice cube.
An ice cube. And what do you think the molecules in the ice cube are doing? If they were like Lego.
These snap tight too.
Snap tight too. Okay, we're gonna put that back in here.
Okay,
keep it for now. All right. We are going to look at this ice a little later on.
Okay.
Okay. All right. So far everything we've looked at, all of the molecules are tight together. But let's see what we have here.
Okay. Water?
Water, yes.
Yep, water.
Yes, it is water. All right. And notice what happens when you move the cup.
Mm-hmm.
Do you think you can put your finger in there? You couldn't put your finger in the rock.
Yep, it went in.
So if you were thinking about all of the molecules being Lego pieces, are these ones as tight as they are in the rock and the crayon or the ice?
No. And I noticed that when I put my finger in, the water moves up.
Mm-hmm. So it moves, but does it kind of stay together a little bit? Does it go all over the place, or does it move?
It stays together within the cup.
Okay, so let's
when
see.
you move it.
It stays within. I want you to see if you can pour the water in this test tube.
Okay.
Right. So now the rock, and the ice, and the crayon, they all have their own shape. Does the water have its own shape?
No. It's the shape of the container it's in.
That's right. So if we had a different container, what do you think might happen?
I think it will take the shape of the new container.
Okay, well, let's try it.
Okay. Oh yeah, it did.
So your prediction was right. So we have water that takes the shape of the container that it's in. Now, I know some of these terms might be familiar to you. Do you think you have a guess about which one the water might be?
Liquid.
Liquid. Have you heard liquid before?
Yes. The doctor says drink lots of liquid.
Drink lots of liquid.
When I'm not feeling well, especially.
That's right. I have a liquid here. This one you cannot drink.
Okay.
I want you to open that. We're going to try the same thing, pour it in here, and see if it behaves in the same way as the water.
Okay.
It's okay if you spill it. We have napkins.
Okay.
Do you notice anything about this liquid?
It's thicker.
Mm-hmm. I'll let you play around with that for a bit.
Okay.
You said it was thicker. Thicker than what?
Thicker than the water.
Thicker than the water. Is it as thick as the ice or the crayon or the rock?
No.
No.
It still moves and takes the shape of its container.
You can rest that in here.
Okay.
That one's actually called oil.
Oh. My mom cooks with oil.
That's right, it is cooking oil. All right, I have another liquid here.
Okay. Are we making slime this time?
This can be used to make slime. Do you know what it is?
Soap.
Soap.
Is it soap?
It's actually soap that you use to wash your clothes.
Oh.
Laundry soap.
Laundry soap. Am I pouring it in this one?
Do you think you can get it in there?
We can try.
Do you notice anything about this one?
It's thicker than the oil, and it's moving slower. When I pour it, it comes out a little slower. But it's still taking the shape.
That's a very good observation that you're making. You can rest that in the test tube rack with the other one. I have something else for you to look at. So this container has water in it, but it's heating up. I want you to look at what's happening when we heat up the water. What do you see?
Fog.
Fog, yeah, or steam.
Smoke. It smells nice.
Can you touch it?
Yeah.
Yeah.
Not too hot.
Not too hot. Now we looked at the particles in the rock and the crayon and the ice, and they were all staying tight together. You said like if they were Lego, they would be very hard to break apart. What do you think that means for these particles? I had to look again at this theme.
It's going everywhere, and it's flexible. And
now you said the water takes the shape of its container. Does this stay? The steam, does it stay?
No.
Anywhere?
It doesn't stay in the shape. It just spreads all around.
It spreads all around. That's right. Okay. So I am going to draw a picture. I want you to imagine that we have a super strong magnifying glass and we can look inside all of these items that we have here.
Okay. I'll put my imaginary magnifying glasses on.
So some of these items, the molecules, they are packed so tightly together that they don't really have space to move.
Okay. Do I
So
draw one?
this is what it would look like.
Oh, that's right.
Which ones of these items do you think have the molecules packed so tightly that they can't move around freely?
The rock.
Okay. Anything
and
else?
the crayon.
The crayon? Okay.
And the ice.
And the ice. That's
Forgot the ice.
So we had some keywords. Which one of those words do you think would describe an item that had the molecules packed tightly together like this?
Solid.
Solid.
Okay.
Solid.
Okay. Can I draw a little picture?
Yes, you can draw a picture. One of these has the molecules, they're very close, but they're free to move around within the space. Which one do you think that would be?
The liquids.
The liquids. And how do you know it's the liquids?
Because it moved around when I poured them into the test tubes, but they stayed in the shape of the container they were in.
That's right. So the particles in the liquid can move freely in their container or their vessel.
Okay.